When you declare an array in memory, you can supply values for the array surrounded in brackets like this. So this is going to create a new trainer's array. It's an array of strings. And it's going to be initialized a size of 1, 2, 3, 4, 5 elements. And each of the elements in this order is going to be populated with this data. Now this form of the statement implicitly includes the new string directive, but this statement includes it explicitly. So this is a little bit clearer in what is actually going on. So I'm creating a trainers 1, the second trainers array. It's still an array of strings, but it's newing up a string array and then using this bracket notation. Essentially, this is an object that .NET and C# understand what to do with in order to populate each of the items in the new array with those values. And this works for objects and numbers and whatever kind of elements that you want to create a new string to contain. Okay, so this is really the more complete statement of what's going on, but I think this is just as readable. I don't think you're losing anything by not including the new string statement there, but use whichever form that you prefer. Okay, one thing about this particular notation of using these brackets, either way here, is that you can't supply a size for the array. The compiler is going to calculate the correct dimensions for the array, given the contents within the brackets right there. Okay, and then you can also do this with objects. This is a little bit more complex situation now. So now I'm creating an array. I'm passing it in this bracket delimited set of items. And still a comma delimited list, just like up here, but now I'm newing up writer objects. And again, I can use existing objects as well. I happen to be creating new writer objects here, but I could use existing ones, in which case it would just be the variable that holds a reference to that writer object. All right, so this is a very efficient syntax for creating an array and populating it immediately as part of the declaration with these different object references. Okay, now, so all of the arrays that I've shown you so far have been single dimension arrays. You can also create multi-dimensional arrays if you like. For example, you might like to store information that requires multiple data items grouped together in logical rows. You might create an array like this. It contains the full state names and the abbreviated names grouped together. Okay, so I need to indicate that I'm creating a two-dimensional array, so I'm including the comma here. So that tells the compiler that I want a two-dimensional array. If I was creating a three-dimensional array, I would have two commas in there. A space for one element there, and one element there, another comma, and then another element that indicates that it's three-dimensional. In this case, it's two-dimensional. And so I'm going to instantiate or create this as a string, as another array that's going to create 50 arrays, each of which contain two elements. All right, so I'm going to create state, or then initialize states 00 to Alabama, 01 to AL for Alabama, states 1, so this is now the second row of the array. The first column is going to be populated with Alaska, and then the second array, second element, each of which has index 1 because arrays are 0 based, to AK for Alaska, and then so on. Okay, so this form of declaring an array and initializing everything, a little bit verbose, requires that you type every part of array, every pair of array indexes, and get them all correct. This is very error-prone code. If you start looking at 3 and 4 dimensions, then getting the zeros and the ones and the twos and so forth in the right place and everything can be a little bit difficult. But you can have C# do more of the work to structuring the array, and you can do that using code like this. So this is using that bracket notation again. So I'm initializing a two-dimensional array. C# is going to figure out how many elements, how many arrays are in the first dimension, and how many elements are in the arrays in the second dimension. Okay. And then I can then pass in, because this is an array of arrays. This is where I was talking about the multi-dimensions are essentially array of arrays. More dimension, they're arrays of arrays of arrays, and so forth. So this really shows that this is creating an array right there. Has two elements. That's delimited by brackets. So this is an array. This is another array. This is another array. And then that set of arrays become the array of arrays. And I can go all through that, and you can see that I have all of the states there. In fact, I have more than states. I have Washington, D.C., and so actually I have more than 50 elements. But I don't need to count them. I don't need to know that, because C# is just going to do the right thing and make that array the right size. Okay, so in fact it actually has 54 rows, because it includes Washington, D.C. and the U.S. possessions. Okay, so now let's talk about retrieving data from arrays. When you need to retrieve data back out of an array, you have at least three choices, three ways to do that. You can retrieve it by its index in the array. And that's what this code does. So in this case, I want the 0th element of the array, the first element in the zero-based array. And so I have a square bracket, the index, and a closing bracket. And by the way, this doesn't have to be a fixed number. That can be a variable. All right, if I want to access the data in a multidimensional array, I need to specify the indexes of which array and which element in the array that I want. And so that's going to retrieve that value and display it there. Another option is that you can loop through the data. So if I want to display all of the instructors, I can use a for loop like this. For each would work as well. I'm going to start at 0 for the 0th based, although if I really only wanted the last 3 instructors, then I could start at a different position. I'm going to go as long as there are elements there. The length property of an array returns the number of elements in the array. And then each time through the loop, I'm going to increment the loop counter variable. And that's going to write out each of the instructor names on a line in the console window. And I can do that same thing with object arrays as well. Okay, and then the third major way of retrieving the data is to use a for each loop. So this is going to loop through all of the trainers. Each time through the loop, the trainer variable will get a reference to that element in the array, and then I can write out the trainer's name. Then I can do the same thing here for objects. So I'm going to loop through for each of the writers within writer's array. WRT has a reference to each writer. And then I'm going to write out the writer to the console window. Now what's kind of interesting about this is that writer is an object. It's not a string. I need a string for the console window. And so what the writeLine method does, it sees that this is an object and will automatically call the toString method for me. So if you recall, if we come back up here to writer, we overrode the toString method, and it's going to say Don is from Alaska. So that'll be what's displayed in the console window. Okay, then another really nice technique is that you can pass arrays as a parameter, actually pass it as an argument to a method that has an array defined as a parameter of that method. So here I have a method that is going to print the elements of an array. I'm passing the string or the array name so that I can use it in the code, and then the array itself. So this works because this array is an object. So I can pass objects as parameters to arrays, and I'm able to then use that array within that method. All right, and here's that print elements method. So I have parameters for the array name. I have the array to print. notice that it's defined as an array of objects because I want to be able to use this method with any kind of array that I pass to it. All right, so what this is going to do, it just works on one-dimensional arrays. It's going to print its contents to the console window. All right, so the first thing it does is it uses the rank property of an array. This is one of the properties, the members of the system.array object, to make sure that it's a one-dimensional array. If we needed to print two-dimensional arrays, we'd need to write some different code. But so we're making sure that this is a one-dimensional array. Real application, I would have an else down here that threw an exception or did something. And then I'm going to use a for loop to loop through each of the elements of the array, using the length property of array to print to limit so that I don't overstep the end of the array. And then I use the array name. Here's why I need to pass it into the method, because I want to display that. Then I display the index value, which is going to be the value of I. And then I retrieve that value to print. Okay, so that was a long method, a lot of things going on here. Let's finally run this code and to run this create and fill arrays. Select B. Okay, and a lot of things going on here. Okay, so the first thing is, remember that I created that instructors array, and then I copied the array and added some new elements. And then I created that people array and assigned, or actually created a reference to the same array as instructors, changed the first element, and then I printed out instructor 0. And that you should see now that instructor 0 is now Tommy, because this had a reference, these variables have a reference to the same array. Okay, and this shows various ways of looping through the different elements. There shows that overridden toString method of the writer object. And then you can also use a for each as text and different objects. And then here's the result of passing the array to that print elements method, and it prints out the name of the array, the index, and the value of the element.